All right, so good afternoon, everybody.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
So we are going to be taking a look this term at waves. All right, that is page 83 of your textbook. So you could turn to that page if you have the textbook. All right, I'm going to write a few notes here. So first we have to define what is a wave. All right, can anybody define what a wave is for me? Can anyone define a wave for me?
A wave is a continuous stream of regular disturbances.
Ah, yes, it's right there, right? So a wave is a continuous stream of regular disturbances, right? Now that begs the question, what is a disturbance?
There might be a change.
So interruption.
Right, so an interruption, right? Now, let us think of a disturbance as if I have a string, right? And I pull the string tightly. All right, so suppose me and one of you holding a string and we hold it tightly and I just raise my hand up and down once. What do you think you would see along the string?
Something like a hump.
Something like a hump traveling along the string, right? So that hump is your disturbance, right? Your disturbance is a displacement from your rest position. So let's write that disturbance right? So this is a displacement from the rest position. Okay, good. So now that we know what a wave is and we know what a disturbance is, right? So we could say a wave is a continuous stream of well, displacements from rest position. So it have another definition of a wave that I prefer. So a wave we could talk about. So the wave is also the propagation of energy. All right. Now, what does propagation mean? Anybody know? All right. So anybody know what a propagation?
So it's like another word to movement.
Yeah, it's a movement. Right. So just like how I was explaining just now, if I move my hand up and down once, you would see the hump moving, right? So that wave is propagating, and that kind of wave is called a pulse. It's a single disturbance. Now, if I move my hand up and down continuously, this is the interesting word right here. Continuously, you will see a regular chain of disturbances. Not so?
Yes, sir.
And that is exactly what a wave is. So it is the propagation of energy. Now, what kind of energy am I propagating in that example? Anybody can tell me? I'm moving my hand up and down. What kind of
energy?
Yeah, so that one would be kinetic energy, right? Nice. So there are two types of waves, right? Two types of major waves that we're going to look at. So there are two types of waves.
Pulse.
So can anybody tell me what the two types of waves are? Or what are the two types of waves?
Transverse and longitudinal waves.
Very good. So somebody did the research, right? Very good. So we have transverse waves. Right, so transverse waves, what are transverse waves?
So a wave which oscillations are perpendicular to the direction of the wave's advance.
Right, very good. Right, so it is the disturbance or the vibrations are perpendicular. Anybody can recall what perpendicular means?
It's at a 90-degree angle.
Yeah, so a perpendicular thing is 90 degrees, right?
Yeah.
Vibrations. Now we are dealing with waves, so we do the whole cycle. So it's either 90 degrees or 270. Right? If we was to look at this kind of thing here, we have 0, 90, that's perpendicular, 180, 270, and 360, right? So the wave could either be, and yeah, we'll see that when we draw it. All right, so that has vibrations perpendicular. Dicular to its direction of propagation. Well, I want to use a different word than propagation. I want to use direction of movement. Right? So if my wave is moving this way, where would my disturbances be? Well, my disturbance would look something like this. Right? It looks kind of sinusoidal. Right, let me just draw a little better one. Something like that, right? Now we could draw a
Yes.
better wave, it's fine. But notice that this is perpendicular to my movement. My movement is along this way, right? But my disturbances is this way, right? So this is a perpendicular movement. Now we could also use we could also list the particle motion, right? So the particle will move along the graph. Right, so it would move in the direction perpendicular, something like that, right? So the particles of the particles that the wave is disturbing will move in the same direction, but the same disturbance. Right, so they will also be perpendicular to the movement. Right. Okay, and well, you can see that the source vibration is up and down. Right, if we move our hand
Yes,
up and
sir.
down, that is exactly what's going to happen. Right. Okay. I could give you some examples of we give two waves there. It is an electromagnetic. Well, electromagnetic is one wave, but it's two different properties. It's both electric and magnetic, right? So when we come to see that, we'll see that. Let's not get too caught up right now. So the other kind of wave is what? You tell me.
Transverse.
No, wait, we
No,
just did transverse.
Longitudinal.
Longitudinal, right?
Longitudinal, however you pronounce it.
Longitudinal. All right. So what is a longitudinal wave?
Where the vibrations is parallel to the movement.
Right. So the other one was perpendicular. This one is parallel. So this is one. that has the vibrations parallel to its direction. Of movement, right? Okay. Nice. So what does this look like? Just like how we drew the transverse wave, what does this longitudinal wave look like? So let's assume we have a spring. I remember from when you was doing Hooke's law,
Yes, sir.
right? So we have a string and then we have a compression here. Then we have an extension here for rarefaction, right? So we could say that this point here has high pressure, right? Because if you squeeze the spring, you compress it, right? And notice that
Yes,
that movement is parallel to your propagation, because your propagation is this way, right? Yes, the propagation is this way and it is moving in that same direction. So high pressure. And this right here is low pressure. Right, so we know what a longitudinal wave is, and we know what is a transverse wave. So let's just say what this part is here. This part is called, we are very creative with names. This is called a compression. And this here is called a what? Well, a rarefaction, right? But I don't have enough space to write to this. So I would just write a note on. Right, so the note I would write is longitudinal waves are characterized by regions of high pressure and we call that compressions. And regions of low pressure and regions of low pressure, which we called rarefactions or rarefactions or refractions. Right, RERE fractions. Nice. Now, can anybody give me an example of a longitudinal wave?
A microwave, the microwave thing.
A microwave? No. A microwave is an electromagnetic wave. So that is a transverse wave. Right? Because microwaves are light waves, right? So we would come to see that, don't worry. Right? So what are some examples? We have sound waves or any kind of matter waves essentially, right? If we were to drop a speaker, so let's see. And if we were to draw a speaker like that, and the sound will be it will be loudly here, and it will start to spread out, right, along an angle. Okay, and then it would have probably a rarefaction here. So this is like a compression. The particles here is like a rarefaction. It has spaced out. Then the next compression. Right, so this right here is a rarefaction. This is a compression, and it would propagate like that. Right, so this is a R and then a compression here again. When it compresses the air particles. Okay, so this is a rarefaction, right? And these are the particle movements. The particle movements they are in a series of compressed and rarefactions, right? Nice. And how do we make this kind of wave? Well, we move back and forth, right? Rather than up and down, we move back and forth. Like if you play with a spring and you move the spring back and forth, you would see the compressions and the rarefaction. That's all?
Yes, sir.
All right. Okay, nice. Okay. All right, so now we want to talk about the last kind of wave. We need to talk about progressive waves and stationary waves. All right, progressive waves and stationary waves. Notice that this is an introduction to waves. That is why I'm not going fully in depth yet, right? From the next class, we would be talking about wave parameters such as amplitude, phase, periodicity, frequency, and so on. I think today we could start the amplitude of a wave, looking at the time, and we would see where we could go from there. All right, so a progressive wave. All right, so a progressive waves. Anybody could tell me what a progressive wave is? Now these are a different classification of waves, right? They could also be classified as these. So what is a progressive wave?
A wave that is transfer
Right, so
energy.
these are those that is transfer energies, yeah.
Stationary, a stationary wave.
Those that transfer
Transfer energy from one point to the next, I think, some sort.
energy
From one point to the next.
from one point to the next, right? Yeah.
Yeah.
To the next. Nice. Right, and we don't want to go too deep into stationary waves, right? These are like waves that do not transfer energy, right? So standing waves or stationary waves. Right, and this is beyond the scope of your well, of your course, because what we do in here is a CSEC course, right? We're not interested in stationary waves yet. Right, maybe when you want to do Form 6, you would see stationary waves and all of that. Right, so stationary waves do not, right, we just defining it, but we're not going in depth with it. Do not transfer energy. Full stop. All right, so cool. It looks like we have 10 minutes remaining, so let's just talk about the amplitude of a wave quickly. So this will start the next class, but we'll end this one. Right, so the amplitude. So this is wave parameters. Right, what can anybody tell me the amplitude? What is an amplitude of a wave?
So the maximum displacement would distance move by points on the vibrating body or wave.
Very good. So it is the maximum. So this is the maximum displacement of a vibration or oscillation, or of the vibration or oscillation. S. Right, so it is the maximum displacement of a vibration or oscillation, but we must define from what point, right? From its what? Well, from its mean position or from its rest position, right? From its rest position. Right, so if I was to draw that, what would that look like? Right, so I would have a wave. Right, let me just draw this a little better. So this wave has two, well, has an amplitude. Let's say that this is our maximum displacement here. So this is our amplitude A. I'm usually denote amplitude with a capital A, but this here is also an amplitude, right, which will be negative A. All right, and the wave is continuing. All right, so notice that this here is not an amplitude because this is not the maximum displacement. This one is the amplitude here, because it's the maximum displacement from the rest position. Similarly, this one is an amplitude because it is a maximum displacement. All right, so that concludes
Yes,
today's
sir.
class.
Yes, sir.
All right, that concludes today's class. So any questions on this before we close off, or everything is okay?
Everything
I
good,
just,
sir.
everything
Yes, sir, good.
okay, sir.
Okay, no problem. So thank you for tuning in. All right, so don't leave yet.